και είχαμε ένα μικρό θεματάκι εδώ πέρα έτσι λίγο με το bandwidth, αλλά εντάξει.
Εντάξει. Hello to everyone. Thank you for attending this session. We are still waiting for some of our speakers to start. We will be starting in about 10 minutes. Christos is with us. Christos will be presenting later on activities on primary education. The live streaming has already commenced, so this is not just a private room. We are live. But in the meantime, we can wait for our speakers to join in, and we'll talk to you in about 10 minutes. See you in a second. You can also use the chat if you have issues with the sound, and of course for questions that we will try to address in the final 10 minutes. The information that I'm just is going to be repeated. So please bear with us until everybody has joined in. At some stage, I also might ask you to turn on your cameras, because I will like to take a nice picture of the event as well.
Ciao, Stefanos.
Ciao, Luigi. How are you? We are still waiting for some people to join in. We're already live and testing the YouTube connection, so this is not a private room.
Okay.
Angelos is with us. Christos is with us. Eleftheria will be joining us later on. So,
hi everyone. Can you hear me, Stefane?
Yes, we can hear you fine, Angele. We can hear you fine.
Okay, great.
Angelos, Pierluigi, do you have the share screen function in your suit at the bottom, so you can share your screen? Do you have it available? Can you see it?
I have it, yes.
Good. Angelos, do you have it?
Yeah.
Okay, that's fine. That's fine. So
I'll try to keep my part until 2 o'clock PG's time. Okay, so PG.
Okay, so okay, cool. Yes, very good. We're gonna wait 5 more minutes for people joining, because people are joining at this now.
Okay.
Let me see if I have admitted everyone.
How many people are connected? Are they teachers? Are they students?
The majority of them are teachers. The majority of them are teachers, Luis, and we have a number of them are from Greece, but I see people from other countries as well joining in. But the event is being broadcasted on YouTube, so it will be available to everyone, because it's an open event. So so people, even if people they don't want to join in through the Zoom channel, they will be looking at the YouTube. So me and Angelos, I'll probably looking into the comments in the Zoom, and Angelos, I'll ask Angelos to look into the comments and questions on the YouTube link. And in the end, also, we're going to have some people through the Zoom channel to pose any live questions if they want. So we'll try to sort of coordinate that thing.
Άρα μόνο η κυρία Τοπολιάτη ακόμα δεν έχει...
So on YouTube, our channel is Open Class Workshop Playing with Proton.
Sorry, yes, it is.
Okay.
It's the one. It's the button adjacent above the Zoom link on the program.
Yeah. I'm looking at. Yeah.
Okay. Actually, we're looking at you right now. So
Yeah.
on YouTube.
You did what I asked.
So okay. So now it's me, but I have my camera turned off. So maybe I can start my camera. So it's exactly 2:30. We will be allowing 5 more minutes, and then we can.
Yeah. No problem.
So, Stefanos, I will be looking at the YouTube comments.
Good. Thank you, Agili. And I'll be looking into the comments here.
Okay.
So, we will start in 3 minutes exactly. Angelos, do you have a presentation ready that you want to share? You're muted, actually.
I have a presentation.
Okay. So I'm gonna mute everybody else. So maybe you can put your presentation on. Okay. So just wait a few more minutes. Okay, very good, very good. The presentation is on. I would like everybody now to turn off their mics as we will be starting in 2 minutes. Okay, let's start. Thank you everyone for joining us for this workshop on titled Playing with Protons. Playing with Protons, Angelos is going to talk to you a little bit more about it. It's a very successful campaign and initiative both in Greece and in the UK. And now we are expanding our synergies with initiatives that have that are working along similar lines, such as the INFN in Italy, and they will also be presenting today. Also together with us, Christos Papandreou, who has been in the past a teacher trained within the Playing with Protons scheme, and Eleftheria Tsoulidaki, who has been a Playing with Protons trainer with us in the summer events that we host every August in CERN. As I said, I just want to point out that Christos, being a past attendant of the training event, Playing with Protons focuses greatly on offering the space and on allowing our trainees to become trainers themselves. And many of the teachers that joined us in the past are now our trainers. These are the people who are now sharing with us all these ideas and that they have acquired through the Playing with Protons scheme. Now I'm going to give the floor to Dr. Angelos Alexopoulos, who has been, I suppose, the main person behind the Playing with Protons initiative. And he will talk to you a little bit about the history and the steps ahead. Angelos, the floor is yours.
Thank you, Stefane. Thank you very much, everyone, for joining in this online event. It's a bit refreshing given the recent lockdown. At least in Greece, we are in lockdown from officially today. I suppose the same happening elsewhere, but this doesn't stop us to use online, opportunities. And I think this conference is a great example that we keep on going under this new normal. So I'm very happy that we have with us Pierluigi Paolucci, who is the head and coordinator of a great initiative, the Art and Science Across Italy project. I consider this project as very closely related to Play with Protons, because both projects are actually STEAM projects targeting different audiences. In terms of actually the age of students and that we're looking at. So Play with Protons is focusing on primary school students and teachers, So I'm just gonna spend maximum 20 minutes on this presentation. The aim of this presentation is to give you an overview of why we started this initiative back in 2016 at CERN. I always, use this photograph over the recent years, which I think speaks a lot to the purpose of this program. This is actually a big photograph you see just outside on the facade of the Alpha Magnetic Spectrometer control center at CERN. You may know that AMS is a particle detector which is mounted on the International Space Station, as you see. And it's a great experiment that is taking place over some years now with the aim to study actually aspects of dark matter and antimatter. It's an amazing experiment that has been possible through the collaboration of CERN and NASA. And this photograph is quite striking because you see Mick Storr. Mick Storr has been a person who has a long history and contribution to teacher education at CERN. And you see little Emma. Emma is a primary school student from Hungary who happened to visit CERN a few years ago. And Mick gave her a private visit, Emma and her little puppy doll, you see here. And Emma is, particularly exciting having this tour at the Large Hadron Collider and CERN, the largest laboratory in particle physics in the world currently. As Mick mentioned to me a couple of weeks after Emma's visit, that was actually a lifetime experience for her. The reality, of course, is that children at this age have a natural proclivity to observe things around them and to think about nature, in a very sort of direct and very intuitive way. So it's actually an ideal age to start providing children, with the environment, with the tools, with playful activities to start developing their scientific reasoning. Because children actually pose scientific questions regardless of knowing it or knowing that they do that or not, okay? So the truth is that starting the earlier possible, is only positive. Some studies, especially the Aspires project in the UK back in 2013, having looked at young people's science and career aspirations, found out that starting interventions at the age of 14 or 15 is quite too late, because at that age, students have framed already their views for or against science. So, the work that has to be done at that age, it's much harder, if you like, if we haven't intervened earlier, okay? The reality is that most efforts start in secondary schools. This is not a bad thing. We cannot say that, doing STEM in high schools, is possibly too late or bad. What we say is that it's better if we start earlier, and students that come up from the primary school and, with a fruitful experience in STEM may have, a better, let's say, positioning in continuing, their aspirations towards science. I just want to present something that comes from the teachers and science educators side. A couple of years ago in Brussels, there was an interesting networking event aimed at looking at how STEM works in primary education. So there were many specialists, many teachers there that took part, and they wrote a report that came up with 3 conclusions. Okay, so all of them recognized the need for high quality teacher training. So they identified a gap in continuous professional development for primary school teachers in actually renewing their STEM teaching. The second common conclusion was the recognition for the need to offer teachers access to high quality teaching resources. Okay, teachers are superheroes, but they need support. They need help. They need methodologies to be able to develop their own customized teaching resources, but also to have access to high quality teaching resources developed by educational institutes, developed by large research infrastructures, etc. And the third point that they agreed on was the need to create a STEM culture. Now, this might sound a bit vague, but developing a STEM culture is really important in a school environment. There are many things, many subjects, many competing interests, and many, if you like, too much information that is given to students at this age, both in school and outside school. All right. What we need to agree on is that this STEM culture refers to a shared understanding among the key players, the key providers of STEM education, that they have to provide students with a sense of belonging, with a sense of responsibility, and with a sense, if you like, of emotional attachment to the beauty of science. Therefore, when we started this primary teacher professional development exercise at CERN in 2016, we considered the evidence in the literature, we considered actually the needs of the teachers, and we came up with 4 main aims of the program. We are lucky to offer primary school teachers the opportunity to experience the unique culture of CERN, okay, because Playing with Protons training courses are taking place in CERN, okay, so this by definition is a big advantage of Playing with Protons teacher training. But it's not only that, it's not only a visit to the laboratory, it's a structured 1-week program aimed to give teachers the opportunity to experiment with hands-on activities, the opportunity to transform their school classroom in a science laboratory without having the need to provide the infrastructure that sometimes costs money, especially for public schools, and more specifically for public schools in remote and underprivileged areas. So we can do that with simple, everyday kitchen materials. And this actually is a test bed in order to increase their confidence when teaching physics. Don't forget that primary school teachers are generalists. Most of them don't have a degree in physics, and they have to teach many subjects besides science. They have to teach history, they have to teach geography, they have to teach everything really, at least in Greece, but as far as I know, this is happening in many European countries. So when we ask them to bring new ideas and new methods in teaching physics, first of all, they have to develop their self-confidence in doing so. And so how do we develop this confidence? Is by giving them the opportunity to co-create creative lesson plans that actually sometimes go at the edge of the primary curriculum in schools, but we also give them the, if you like, the mindset to connect, cutting edge science with existing aspects of the curriculum, okay? And the aim is to increase the interest, the motivation, and in my view, one of the most important aspects is the wonder of students, which is includes this emotional attachment, if you like, to science. And finally, the aim is when they leave CERN and they leave this training course, they become somehow, like unique ambassadors of science. And we try to support them to share what they have acquired during this training course, and to share it, first of all, with their peers, with their fellow teachers, with their principals, to communicate that with the students' parents, and to make the best to increase the awareness of the local community. Okay, so we started like in a very pilot format back in 2014. We had the opportunity to bring some primary school teachers from Greece. We had an amazing physics teacher working in a private school, in Hill Memorial School, Tina Nansu, who ran an amazing set of activities, of STEAM activities in her classroom. So that gave us the confidence that it is possible to introduce primary school students into particle physics. So we started the pilot course at CERN in 2016, bringing 10 primary school teachers from all over Greece through a competitive process. And then we expanded to the UK the following year. The fruits of these 5 training courses that took place at CERN since 2016 are documented in a paper published last year in Physics Education. This year we're supposed to continue this effort, but due to COVID, we had to postpone the training courses at CERN for next year. So that's the reality. We've got the support of an impressive and continually increasing number of institutions and bodies. First of all, we got the support of all the LHC experiments at CERN, but also universities, science education organizations like the Ogden Trust in the UK. We moved beyond Europe, and we have, as a supporter, the Perimeter Institute in Canada. We tried to self-fund the training courses, so we looked at private funders from foundations, and most importantly, we integrated our training courses in the context of large European initiatives, foremost the Creations Project, and more recently with the Open Schools for Open Societies and for TSR and Reinforce. It's important to mention the European projects because they provide, if you like, not only the network of teachers, but they provide us with a structured and scientifically based methodology that we can actually optimize the delivery of the aims that I mentioned just before. So far, we have done 5 courses at CERN in 2 countries, in the UK and Greece. And the implementation of playing with protons in schools is translated into reaching out to approximately 9,000 primary school students in more than 150 schools. Just to give you an example of the multiplication ratio that is taking place in our courses, is that one teacher that comes to CERN as a trainee and finishes off the course, then goes back to their country and engages 6 more teachers from the same or other schools, and together they reach out to 180 students from 3 schools. So this is the multiplication equation, if you like. One teacher who takes part in our course reaches out to 180 students, 3 schools, and works together with another 6 teachers. We had some awards and recognitions over the years, one of which is the Particles for You competition that was organized by the International Particle Physics Outreach Group in 2017. So the first prize for the primary school sector was given to Play with Protons School. And we also had some other recognitions and awards taking place in the context of competitions, international competitions, and science festivals. I'm just going to go through some of the works done by our participants over the years. You can see on the left the works done by students working in a particular school in Greece. It's an underprivileged intercultural school, and I'm saying underprivileged because the student population comprises pupils from various countries and mainly from low socioeconomic background. We also had, as you see on the right, students from a remote and small schools, but with an amazing capacity for bringing innovation. That's the case of the primary school of Vitina in Peloponnese in Greece. And you can see down the photograph of a theater play that the students put together. We had cases like the one in the 6th primary school of Nausa. That was an amazing outreach effort that the participant brought together a prefecture-wide STEAM activity that took place throughout the school year, brought together 14 schools, all the primary schools of the prefecture, and it had an amazing engagement footprint. And one of the highlights is, of course, the second minority primary school in northern East Greece. That's another special case of a school that Marina Mola, one of our greatest ambassadors of Playing with Protons, internationalized Playing with Protons by bringing together, not only Greek schools, but also schools from Turkey and Italy, as far as I remember correctly. So the course has been evaluated positively by our participants over the years. They thought in the vast majority that the course was relevant and useful to them, that has met their expectations. They like the organization and how we run the course at CERN, and they strongly recommend it to their colleagues. And that's actually quite evident from the development of this teacher network. We also contacted teachers a year later after their participation in the course, and we asked them, what was the effect on their creativity, on their interest in physics, on their confidence, and the extent to which they share their knowledge and experience with their colleagues. And the most striking result is that all of them said that they became more creative with how to teach physics. And creativity is a main aim of the project. I'm going to skip that quote. You can read more on this paper. And I'm going to go now to the student impact. During the creations project, we monitored the effect of certain interventions on students' creativity and science career motivation. So thousands of students, including many students in Italy that Pierluigi will mention in a few minutes, filled out a questionnaire. And this questionnaire had also some visual elements. So we asked students to look at this, zebra lines, the star and the pig's tail, and etc., and to try to make associations related to science. One of the schools that I referred to earlier on, this remote school in Peloponnese, one student, wrote down that one student actually that has, for a Greek audience, had some problems with spelling. He's not good in Greek, but he's very good at making associations with these things. So he said that, you know, these zebra lines, the rectangulars, they look like, you know, the scintillators that are used specifically for the CMS experiments, the tangent crystals, actually, for the electromagnetic calorimeter of CMS. Another one saw this thing, and he said that it reminds me of the collisions that are taking place at CERN. And actually, he was quite right. And the third one, he said, "What do you think of this? Do you make any associations with science?" And you know, he thought that this reminds him the LHC, the accelerator complex of CERN. But now let's move on to some more concrete quantitative evidence concerning the playing with protons course. The evaluation team from the University of Bayreuth, together with the Ελληνο-Γερμανική Αγωγή team, published a couple of papers this year, which gives some evidence of the effects that the school interventions in the context of playing with protons had on students' creativity and science career motivation. Specifically, I'm going to refer to the newest paper titled STEAM Teaching Professional Development Works. And they found out that they compared actually the science motivation of teachers before and after the intervention in school. And they found out that the students showed higher levels of two types of creativity. You can see that on the top left box plot. You can see that the students developed higher creativity and higher self-efficacy, which is a key factor in the process of student learning. Okay, so developing self-efficacy makes you feel more capable of pushing your cognitive and your affective, you know, limits towards, you know, becoming more master, you know, in learning a subject. So they found out that creativity enhances self-efficacy, which altogether leads to a higher sense of motivation concerning science careers. I have to note here that we are talking about primary school students for which science career aspirations are not as developed as it happens with a 16 or 17-year-old student. Okay, so that's why you see on the bottom left box plot that concerning the career motivation per se, there was no change in students before and after the intervention. And this is quite normal. You know, we don't expect a 10 or 11-year-old student to have a concrete, you know, aspiration about their careers. Nevertheless, we found that, playing with protons boosts their creativity and boosts their self-efficacy. So in conclusion, we think that playing with protons has proved itself, has reached its aims, and represents a rather successful primary teacher professional development opportunity. The second aspect is that based on this evidence that has been published recently, what teachers do in their classrooms, you know, for a school year, the participants of Playing with Protons, which actually deserve congratulations. And Christos Papandreou is one of those teachers who has done, you know, a big extra mile in this direction. And I think he should feel proud, and many others of our teachers, the work that they have done, the innovation that they have brought into their classroom has a positive effect on their students' creativity and self-efficacy. But what do we do now? How can we make STEAM initiatives? And I pass the baton to Pierluigi. This is a question for you, Pierluigi. How do we keep on delivering, innovative activities in STEAM under this new normal of COVID. Many schools are closing. We are going to have a school year with, I don't know, continuous closures, opening closures, etc. How do we bring institutions like INFN that has a large outreach potential to the communities, and how can we actually transform the delivery of both teacher training but also of school interventions under this regime that we are living? So I think that this conference is on the right direction. Open and distance education has become over the years, a far more important reality, actually, and a platform for continuing doing so. So I leave this small presentation with a question, and I'm sure that Pierluigi Paolucci might have some good examples to share with us in this direction. Thank you very much.
Thank you, Angelos, very much for this presentation. As I said, if for questions, we will. If you have a question for Angelos, we will try to have 10 minutes in the end. We will try. I can't promise, because there is another session after us. This day is full of parallel sessions, and there is one coming right after this one. I'm going to give the floor now to Pierluigi. Pierluigi, just talk to us just 1 minute about yourself and who you are. It's better than me trying to introduce you. Thank you very much.
You're welcome. Okay, I will try to share my slide. So just a second here. Okay. Do you see my slide now?
Yes, we can see it. Yes, okay. Thank you very much.
So my name is Pierluigi Paolucci from Napoli. I work for Istituto Nazionale di Fisica Nucleare, that is the biggest research center in Italy about physics, and I collaborate with CERN. I have been 5 years at Stanford during my postdoc position, and then moved to CERN, and then finally I decided to come back in Italy, and in particular in Napoli. So working so many years with the student, with professor, with school, and also with colleagues, my feeling was that part of the student, let's say between 10 and 18, are not naturally attracted by the science because mathematics. Mathematics is not so, let's say, natural, is not so easy for all the students. It's clear that it depends by the teacher and the professor that you meet in your life, but sometimes when you start talking about science, you already see that there are students that stop listening because there is a formula, for example, or there are numbers. So this is why with Angelos and Michael Hawk, colleagues from Austria, we decided to try an experiment and try to convey scientific ideas using art as a language. We start with high school, but then we decided to move also to younger students. That means between 5 and 12. So let's say that the Art and Science Across Italy project is an Italian project. The budget comes from INFN and from CERN and from sponsor, local sponsor, and is addressed to the student and teacher of all, for the moment, Italian lyceums and art school. In the future, we hope for all the European lyceum and art school. The project is 2 years long, so this is why we ask students that are 16 and 17. So this is not okay for students that are already at the last years. And then at the same time, we have art and science kids that is for students from 5 to 12. So I will report about the general view of this project, and then I will give to you some information about the older student and the younger student. So the goal is to attract students to science and to the research that we do in Italy, in Europe, at CERN, everywhere, using different languages. And we decided to use art because art is a natural language for most of the people, especially in Europe. And if you ask to a student to give a comment about a very popular artworks, they are almost ready to answer. If you ask something about physics or chemistry, they prefer to don't answer. This is for the previous reason that I try to explain. There is a sort of, let's say, they are not comfortable with the so-called hard science or mathematics. So the creativity is essential in art and science, and then I will try to do the example that I do to the student. We want that they learn how to design a project. So they have to design an artworks, and then they have to realize it. They have to do it. And then the fourth keyword is the working in group. So we ask students to work in group. 3 people, this is very important, especially when they are young, because they learn how to communicate and how to try to convince the other person of the group that there is an idea that is better than other and so on. So we open a sort of discussion around. So right now we are at the 3rd edition. The first 2 has been done in person. As Angelo said, this is a special edition. It will begin in December. It will be online, but the idea is to expand a little bit the project because there are too many activities online, in my view. And so we are thinking about some online activity in which the students are very active. They are not passive, are not just seminar, but they have to contribute. So they have to participate, they have to play. So in the first 2 editions, we had about 7,000 students. You can see all the information in our website. And the student comes from all the lyceum. So that means scientific, but there is also lyceum in which you study music, or you study art, or you study Latin and Greek, and so on. So we have many different kind of lyceum, and this is open to everybody because we want to attract all the students to the science. So it's 2 years long. When we do in person, we do seminar, we go at school, or we invite a student to come at the university. We have 15 cities right now in Italy that are participating. And there are also people a little bit far away from the city that can move and come. So we do seminar at school, we do round table, we go with the student to visit the Science Museum and Art Museum. We invite the student to visit our laboratory at the university or the National INFN laboratory. We organize some contests, and we invite students to watch some movie or some theater about science. And this is the first year, the one that we call education. The second one is the creative one. The students have to design and build artworks. And then we have local exhibition. The winner go to the national exhibition, and the final winner get award. The most important one are master. We fully pay a master of 5 days at CERN or in one of the national laboratories in Italy. So why art and science? I like to report the example that I do to the kids because they have a lot of fantasy. And so I start asking to the kids, what do you think about an artist? What he does during the day? And the answer is, the artist is someone that is dressed in a strange way. They go around, they walk a lot, they sit down in the bar, to the restaurant, they talk each other, they discuss about philosophy, and then at a certain moment, they have some idea, so they stop discussing, they go and they produce an artwork. So this is, in average, the idea that they have, the kids, that means between 5 and 10, they have about the artist. We do the same question about the scientist, and they say, oh, scientist is a very precise person. He loves to work with numbers, with equation, with formula. They are dressed in a standard way. They are not elegant. They say in this way, they are not elegant. They like to play because for them, when you see someone that look to the space on play in a laboratory, is a sort of game for them. So they like to play. Okay. And then finally I ask, okay, now tell me, who is this one? This is a scientist or is an artist? And here we open a very nice discussion because 50-50, they divide in 50-50, but a very strong discussion because they see some color, they see some sort of picture on the whiteboard, and so they say this is an artist, and is also the dress, no? Looks like a clever guy, so this is an artist. The rest of the people, the 50, the other 50 say, no, look, be careful. There are some formula on the whiteboard. You can see some formula, strange formula, but it's clear that this is not an artist because the artist doesn't work on the whiteboard. So this is a scientist. And so this is very nice for us. We go along on that discussion to improve the idea that they have about scientists and artists. But finally, we try to explain to them that they are very similar because they work with the observation. They have to observe the world, the space, everything. The creativity is the core of their work. If you are artist or scientist, it's not a big difference. And they both do test, experiment, exercise. They try new technique. They try to improve their artworks or their theory experiment. And after this discussion, for the kids, it's clear. The concept is very clear. They are similar. They are similar and they work in two completely different fields, but they are similar. At least the way they think about are similar. And another important message that we give is that they have to study. Scientists and artists study a lot. They have to know everything about the past, because if you don't know about the past, you cannot invent something about the future. And this is an important message for the student. Even if they are 17, they have to understand that in the life you have to study if you want to do any job. So how the project is structured, here I can go very fast. So there are many activities, I already told you. When is in person is very nice because we meet the student many times. In the last 2 years, we organized more than 200 seminars and in total more than 350 events. That is a huge amount, but don't forget that we have about 100 more than 150 research in Italy that are contributing in every city. So we have many activities that are going in parallel. Then we go to the creativity phase. So this group of students is completely free to choose one of the scientific theme that we discussed during the first year, and they have to design an artwork. So they don't have any restriction. There are some economic boundary and some other restriction because they have to go to a museum. Okay, but in any case, they don't have the restriction, and they can use any artistic form because any artistic form is welcome. And we really get almost all the possible artistic form we know right now. During the design, we go to the school, we discuss with the teacher, we discuss with the student, we try to help them a little bit in producing a nice artworks. And so there is some feedback between our world, the scientific world, and the school. Finally, we have exhibition. So every city organize a local exhibition in which all, and this is important, all the artworks are exposed. We don't do any selection because the students are very happy to see their artworks in one of the most important museums in Italy, the Leonardo da Vinci in Milano, Archaeological Museum in Napoli, Palazzo del Cinema in Venice, and so on. We were very lucky because we got a lot of important places, and Angelos has been invited many times to look with us, to prepare with us the exhibition, and they are very happy. When they finally realize that after many seminars, after many discussions about science that can in principle be boring, they have an artworks, and the artworks really go in a museum. At that moment is their artworks. So they start inviting friends, parents, everybody, because they say, come, there is my artworks in a museum, and they are very happy. So here you see some picture of the national exhibition. The first two editions have been done in Napoli in the Archaeological Museum. We invite all the students, teachers, and research to Napoli for 2 days. We visit the exhibition, and then we do an award ceremony all together. Here you can see some picture. This is the exhibition in Padua. This is one of the most important historical palace in Padua. Here is the Accademia delle Arti del Disegno, that is a very ancient academy in Italy, in Florence. And all the artworks that you see are done by the student. Here is an example. This was a very nice artwork done in Roma last year. Science is female. So science is for women, and this was the way these 3 girls decided to express this idea. Here you see that we do all the kind of works. This is the Italian, here, the president of INFN that is working with us. So you can see that we really stay all together, because for us, the moment in which with the student you build the exhibition is a very nice moment. And here is in Roma, is a Mattatoio, is a very big open space for exhibition. So you can see how many people really come to the opening. We were more than 400 people, and you can imagine how happy are the students when you see people around, people that make questions to your artworks, try to understand why you did some things. And one of the typical comments that we get is, sorry, professor, that I understood so late that at the end there will be a so nice exhibition and so on. So at beginning is not so easy for them to understand. This is the national exhibition in Napoli. So you can see here on top right that there are many different kinds. There are puzzles, for example. There are also some idea that I will show to you a couple of ideas. So there are not only standard artworks, they really have a lot of creativity, and so they are able to produce almost everything, from video to picture to painting to any kind of artworks you can imagine. This is the ceremony. So we were 800 people here waiting for the winners. And those are the two first that I like to explain in a second. The first one on the left, that is the first at the national competition, is the expansion of the universe. The white ball here is before the Big Bang. And then the idea of this cube expansion is the four-dimensional expansion. So not only the space expansion of the universe, but also the time expansion. So this was really a clever idea to add the time, a fourth dimension that is not so straightforward. And another nice idea was that here they have a mirror. So if you watch, if you see on the top, you see many times the same picture reflected. And so you really have the idea of something that is expanding in time and in space. This other one that was the third, if I'm not wrong, the third place, they understood that we make collision with proton, and after the collision of proton, we generate new particle and we make picture, and we like to color those particles to recognize them. And they did a color accelerator in which they try to collide a ball full of different colors and produce similar picture here in the middle. You can see when the ball explodes, you produce a picture that are not particles, but are colors. So this is really another smart idea that can really let you understand how three guys of 16 years old can really understand what an accelerator means, and also the output of the accelerator, particle accelerator is producing, and doing something nice, because those are very well done. Okay, and then there are the awards. We give a lot of awards to everybody. We have some gadget, your t-shirt, some cap and so on, and they are very happy about that. And then finally, we do a public event in which we have the NFN president, an expert of art, a journalist, and an actor. And all together they discuss about art and science. So why there is this link between art and science, and why the creativity is really behind all the kind of art that you can imagine. This is a short movie just to let you understand that we really are 100 people working for 2 years. We have architect, engineer, technician, because every time you have to build an exhibition, and you can imagine that we don't have billion to invest, we have to do by ourselves, with the help of the student, with the help of the teacher, with the help of the school, but mainly with the help of INFN, university. We have 20 universities joining the project in Italy, and also with the help of CERN. Okay, now one of the last art and science kits. This was done in person in 2018. So we stay for 4 months, once per week in the school with 100 students. We were for research, playing with them. So explain science, but mostly playing with them. Playing with them means build artistic artworks or do some physics experiment, do some mathematics games all together. At the end, they were very happy. If you see how they judge, we only got 10. It's really unbelievable. This was one of my best day in the life. This was the ceremony, and you cannot imagine how they were waiting for understand who was the winner. It's clear that we gave so many awards to everybody that almost all were the winner, but the first in the rank were the 3 that you see here, and they were really happy. Now they are older, and if they meet me in the street, they are really happy about that. It was a fantastic experience for us. 2020 was online. It's a completely different story. We had, let's say, the first meeting, 100 people, the second around 50, and the last one around 20. So we did only 3 events. We got many artworks online, and in any case, we did a selection. We sent award to them, so they were almost happy. But the big difference doing this in present than online, in my view, is enormous. But let's see the positive aspect. So this I like. We have 63% of female, so we have more male than female. The distribution in Italy is completely not interesting. And this is how the student between 16 and 18 have answered to the questionnaire. For them, the most difficult part was the project and build artworks. The working in group for them was okay and was nice. The project was okay. They say that they understood how the research and how the artist works. But for them, here you can see that it was very difficult made the artworks. So go from an idea that can be nice to something concrete was very difficult. We know that this is the difficult part of the project. So now we are opening the project, discussing with Stefanos and Angelos to Greek school. We are also inviting school from other European country, because I think that after 2 editions, we are ready to move toward the European competition, in which we try to understand also how different culture and different school organization react in this kind of project. So we would like to invite the Greek school to participate into the 3rd edition, having a local competition in Greece, and then the best artworks will be moved in Italy, exposed to the National Museum, so they will be part of the final competition. And the idea is to invite some of the Greek winners in Italy for a master in one of our Italian national laboratory. I think that the best one for the student is Roma, because it is the place where you can really mix art and science together in a very easy way. So in conclusion, right now, we are going to start. We have 13 Italian cities. We are around 100 schools registered. That means 10,000 students, and we really hope to have school from Greece and also from other European country. Here you have some link, the link for the registration, but in any case you can contact me, Angelos or Stefanos to understand how to do it. And thanks a lot.
Thank you very much. Thanks a lot, Pierluigi. This is fantastic news. We are really excited about this, obviously the arts and science competition opening up to Greek schools. We are yet to put together the final touches on the actual competition. And of course, we are still, we are in contact with the Ministry of Education to also give it the formal go ahead. But we have some time in our hands, because we are talking about events that will be taking place in the next full year. Getting the academic year, this academic year and the beginning of the following academic year as well, the school year we mean, 21-22. Everything, of course, depends on how the COVID-19 situation develops and whether we are able to travel, but the event itself is a massive event, and it's also a recognition for the thirst that exists in Greek schools to participate in international events and international competitions. And we are grateful to INFN for opening up its doors to the Greek schools. As I said, the final details are yet to be put together. We will make a formal announcement. The 80% of the instructions are there, and they have been uploaded in English and in Greek, and we are very excited to be part of this initiative. I don't know, Angelos, do you want to add something to this here?
I just want to say that I really enjoyed Pierluigi's presentation. I was part of this effort in the first edition of the program. That happened during the Creations project. And I have to mention that what really impressed me was the collaborative spirit of the INFN community, and of course together with CERN. And when you do something creative, you also have to enjoy it. And Pierluigi is a big ambassador of this aspect. To me, represents a scientist with an open mind to society, and the results of this project actually reflect this open-mindedness and this capacity to reach out to communities that we wouldn't even think of being able to reach. And I really enjoyed also the kids edition, even during these COVID times. And we know that Italy, in particular, had a very, very difficult time. Had the most difficult time in Europe, actually, last winter. And when I saw the online event happening with the kids, to me, I had a big smile on my face, and I said, "Wow, great!" I mean, they keep on not only doing the standard edition, but they expand to younger ages that need most help and attention during the lockdown. That was an amazing opportunity, and I just want to thank personally Pierluigi and also the INFN for giving us the opportunity to participate, this year for this amazing time, and we hope that we will be able to find some nice spaces, not as nice as the impressive palazzos, the palazzi in things, but we'll try our best to find some creative spaces to exhibit the student works. Sure. And I just want to say to everyone to go to the Art and Science Across Italy website. It's a very beautiful website with great examples of the student artworks, and gives a precise information on the phases of the project, the partners who have been involved, and also the registration process, which is useful to know, and to give some bits of inspiration So the teachers should go to the website, should see in detail the artworks, and try to communicate that with their students. Even now that we haven't opened up officially the registration, it's great to start looking at the amazing works happening in Italy. Thank you very much.
Thank you very much, Pierluigi. Thank you, Angelos. And now I would like to give the floor to Christos Papandreou. Christos has been with us for a few years. He was one of the trainees in the second round of the Playing with Protons training in CERN. And he's a regular participator in our events. And now he's going to talk to you about a few exciting things that you can do with your students at primary level. Christos, the floor is yours.
Thank you, Stefanos.
Christos, talk to us a little bit about yourself as you upload your presentation. Thank you.
I'm a primary school teacher in Peloponnese, in Pyrgos, which is the capital city of our municipality. Ancient Olympia is a very famous place that is located close to us, about 18 kilometers. My school is a very small school, with about 70 students. There is a very good infrastructure there, but our pupils need really support as regards the level. Here we can see how we introduce the structure of the atom to 5th and 6th graders of the primary school. And you can see how we implemented all the experience we acquired from the Playing with Protons workshop a few years ago. I think that it is a little bit stuck. Okay. Just a few facts before we go further. A few facts about the formal elementary school curriculum, especially for the 5th graders. We provide, the official curriculum provides specific hours on the subject of matter and the material bodies. Mass, volume, and density are the first concepts that pupils are called upon to experiment with and understand using simple kitchen materials and developing easy activities. As regards particle physics, only a brief reference is made about the structure of the atom on the Green Book. Through an interesting but at the same time condensed text, the history of the atom is presented to our students, as well as the etymology of the word from the ancient years, stopping at the level of elementary particles and the quarks. A brief also reference is made about chemical compounds and the way they are symbolized. As regards the 6th graders, pupils for once more are introduced to the microcosm, meeting with the concept of the cell, the plant, and the animal, which is the basis of life, for life, the similarities and the differences between their structure. And finally, they meet a brief review of the concept of the DNA. Although the curriculum has specific limitations as regards what to teach, how many hours which are available for teaching, it is not prohibitive for us, for teachers, to develop extra activities within the frame of interdisciplinarity, which is not only allowed, but also encouraged by the formal education authorities and our institutions. As Angelos mentioned before, these courses, the CPD courses and workshops for in-service teachers like us, provide to us countless opportunities to refresh our knowledge with modern data and the newest practices in the field. They also create the positive conditions for the birth for new teaching ideas, but also the good mood for further development, cooperation, and research. I believe that this opportunity 3 years ago changed my career and my productivity. So, returning to class, back to class, the next step is to develop brand new and really meaningful activities for creative involvement of our students, according, of course, to their age, their abilities, their interests, and to be presented with big ideas in science, giving them the opportunity to experience STEM in a fun and less daunting way. So, in order to help our pupils bridge the gap between their existing ideas and the knowledge about atoms, with the view of the ancient philosophy and modern physics, we can select specific milestones and tell them a brief story about the history of the evolution history of the atom, and give them a good presentation. Pupils like to hear stories, especially the popularized science. So the story of the atom, we begin with Leucippus and Democritus. They discussed within a philosophical, of course, context about the nature and the structure of the atom, of course, with no scientific or experimental evidence. According to them, atoms are invisible, internal, indestructible, unchangeable, and indivisible. Later on, John Dalton brought again the ancient theories about this time and tried to make experiments and measurements on various elements like water, ammonia, and carbon dioxide. Then J.J. Thomson, we know him very well from his job on electrons, by his work on electrons, on cathode ray tubes. He opened the way for a further division of the atom. There are electrons and something else. He noted that atoms consist of electrons which are scattered inside the positive body of the atom, like the raisins in a cake. So we have the first model, the plum cake model of the atom. A few years later, his student, Ernest Rutherford, with his own students, checked J.J. Thomson's theory more thoroughly with a brilliant experiment, bombarding a gold foil with alpha particles. It was really a big idea and a big inspiration to do it, to think and evaluate. Bombarding a gold foil with alpha particles, they found that a few of the A particles were deflected, and this was a big surprise. If J.J. Thomson was right, all the particles should pass through the positive body of the atom without finding any obstacle. But Rutherford and his students observed deviation paths on the screen, meaning that something in the center of the atom was pushing a few particles out at various angles up to 90 degrees. So the nucleus and the 99% of the mass is located in the center, while the electrons rotate far away around the nucleus, like the sun and its planets. So the team introduced the term of planetic model of the atom. So we go now to the classroom with hands-on activities and experiments. And I will show you a video. I hope you can
Για να δούμε και το μοντέλο του Rutherford.
Can you watch the video?
No, we cannot watch it right now.
It is on YouTube, directly on YouTube. So I will show you snapshots.
You will need to switch your screen in order to show the video if you want to share your different screen or something.
Okay, I didn't, okay. Now, I think now it's okay.
Yeah, that's fine. Mm-hmm.
Here we can see the deflected routes of A particles. Most of them pass, but a few of them make an angle.
Ωραία. Τι παρατηρήσαμε σχετικά με τις πορείες που είχαν τα άσπρα, τα λευκά μπαλάκια?
Ότι τα περισσότερα μπαλάκια περνούσαν, ελάχιστα είναι αυτά που επέφεραν πίσω.
Ή έκαναν κάποια μικρή
Γωνία.
έτσι, γωνία. Ο Rutherford, δηλαδή, τι συμπέρασμα έβγαλε ύστερα από αυτό?
Συμπέρανε ότι ο χώρος των ατόμων είναι κενός και η μάζα του μαζεύεται σε ένα μικρό πυρήνα.
Έτσι. Από πού το κατάλαβε ότι είναι συγκεντρωμένη σε έναν πυρήνα?
Επειδή σχεδόν όλα τα μπαλάκια περνούσαν και έλειψε ήταν αυτά που επέστρεψαν πίσω, δηλαδή ότι από κάπου υπάρχουν και επέστρεψαν πίσω.
Σαν να υπήρχε ένα μικρό.
Επόμενο.
Ωραία. Πάρα πολύ ωραία.
So, I can return to my presentation now. Okay. So, you can see a few tips how to construct the previous demonstration. You will need a good Venner or cardboard, batteries, 25 to 30 table tennis balls, and a hot glue gun. Before the demonstration to the students, we try not to reveal the central battery, so it would be wise to pre-install the wooden construction in the room prior to our class. There is no problem if our students notice the perimeter batteries and tell about their observation, but we try not to reveal the central battery as it is the secret of the activity. We keep a distance about 3-4 meters from the installation, and we instruct our students to throw the balls gently so as not to bounce. We make our observations about the direction of the balls. We point the balls that had different directions and angles. How many of them changed direction? We compare these balls with those that had a regular route. So we come to the conclusion that all the mass is concentrated in the middle, in the center of the atom. That was also Rutherford's surprise. Of course, later we can show the secret and the central battery. Later on, we can go a step further to use our own building blocks in order to show the structure of the atom. we use either plasticine, which is the basic element, or colorful candies, very well known. We start from the hydrogen structure. We use a blank template of the atom to bridge the absolutely necessary terminology, nucleus, proton, neutron, electron, and the basic chemical elements with building blocks, the plasticine and the candies, and the students' ideas, existing or not existing knowledge. Later on, we pass to helium. We also give the necessary info about the K and L tracks as the only rule that students should have into their mind. And we'll continue to build the atoms up to the oxygen. Very basic chemical elements. Working with plasticine seems to be slower and productive, while working with candies seems to be a quicker installation, but very spicy. Of course, we encourage our students to work in pairs using the simplified table of the 6 basic atom models we intend to build. They are also prompt to use their pencils to engrave the first letter of each building block. Here in this picture, you can see that initially I had put the atomic and the massive number of the atom, but it was useless. So we remained to the basic terminology. Then blank atom templates and the brief table of the 6 basic elements provided assisted guidance to the students to work alone and independently. And here you can see a snapshot taken at the Global Junior Challenge in Rome last year, in which young Italian students test their knowledge on the structure of the atom using plasticine, and they were very happy and they used these elements the right way. They had no problem. What's next? We make a step further with Niels Bohr, who suggested that electrons are located at specific energy tracks and they radiate only if they change energy status, or when they absorb energy to do the opposite. Bohr was one of the first founders of quantum physics. And the next station was our schoolyard, where we put our bodies inside the model, imitating the movements of electrons around the nucleus according to energy levels. We selected to develop the lithium atom so as we have an easy and clear movement. We made simple hats from colored cardboard, 1 color per particle. This kind of hats helped to have the best view from a drone above the schoolyard. We also drew the nucleus area, as you can see here, and the energy levels, K and L. Finally, we used a volleyball to symbolize the energy pack given to the electron when it is ready to pass to higher energy level. I will show you one more video. A very impressive video. Where is it? Here we go. Here you can notice the orbits of the electrons according to Rutherford, but in a while the girl will throw the ball and give the energy to the electron to change the energy status here. and back again to the previous status.
Christos, you have 2 minutes, okay?
And the drone goes up and up in order to understand that we live from microcosm to macrocosm, let's say. Okay. I'm going back to the presentation. Okay. So we tried, we managed to combine two models, two atom models, one the Rutherford's and the second of Bohr's quantum model. Then, can we go any further? Yes, we can go any further. With Murray Gell-Mann and George Weich that proposed the names of and the nature of quarks, the new elementary particles. Murray gave this name completely by chance to express his surprise for this new and really unexpected detection. Quarks have their own character and flavor. They are of 6 types, written in fractional form with positive and negative signs. So during the teaching process, we have to be careful and patient with our students, giving them enough time to understand the terminology and the values. Of course, fragments are thoroughly taught at 5th and 6th grader. So the quark introduction is absolutely compatible according to their existing knowledge and abilities. In our case, we add and we subtract simple homonymous fractions. Our basic material is plasticine again. We use colors for protons and neutrons, red color for up quarks and green for down quarks. We also use straight or curly lines to represent the gluons, which sound like the glue. And we call it the strong interaction or strong nuclear force that keeps quarks strong together. We can notice carefully the difference between proton and neutron. Gradually, step by step, we encourage our students to draw with their pencils or paint simple outlines, to write down simple terms, and finally try to combine the fragments in order to result to +1 for the proton or 0 for the neutron. A very interesting, quick and easy installation is to combine the checkers of a very popular table game here. It is called Tavli or backgammon. And using pipe wire, we represent quarks, gluons, protons, and neutrons. Then students can also solve this plastic stuff, these plastic elements and terms, trying to put them in the correct order, like a puzzle. It is an amusing and productive game, practicing their memory. This snapshot is taken from Global Junior Challenge in Rome last year at that exhibition.
Christos, you have 1 more minute. Thank you.
Okay. All the previous teaching approach makes sense in the context that children are guided to organize in their mind their existing knowledge and make models that with the new concepts that they meet. On the other hand, we have to assist them to understand nature's real scale. Simulations, animations that visualize these concepts can be very useful. Of course, we can use the PhET simulations, a game-like environment that students learn through explorations a discovery and they test their models with safety. We can also develop a variety of printable worksheets for distributions as extra activities, time, sequence, or matching exercises, fill in the blanks, drag and drop, hot potatoes, digital form exercises for practice and evaluation. Before we enter our classroom, we have admit our students' curiosity. We have to study and to study carefully basic knowledge. A few of these books are here and help me so much in order to communicate and popularize the science to my students. And of course, I got great help from these guys on their YouTube channels in order to further understand the nature of quantum physics and particle physics. So thank you very much for your time, for the invitation, and for your attention. And special thanks to Stefanos Vamvakos and the Καθημερινή Φυσική, who gave me the permission to use icons and screenshots from his website. You can find all this material on my website on the last screen. So thank you very much.
Christo, thank you very much. This was a fantastic opportunity, very rich and presentation, very rich. And actually, you know, we really, one of the reasons that we have people like Christos in our team is because Christos makes an effort to align what we want to do in Playing with Protons with the national curriculum in Greece. And this is something quite important to us because we are trying to build a smart practice that is solid methodologically. Now, I would like to move into the next speaker. Playing with Protons has many aspects. One of the aspects is the one presented by Angelos, for example, that has to do with important CBD training for teachers. Christos talked to us about what we can do using exciting and art-based methodologies and in the classroom. And now we would like to move into a very important aspect that we use, that we value massively in Playing with Protons, and that has to do with trust in science and issues like climate change, for example, and how can we use innovative and interesting and eye-catching approaches to introduce issues like climate change and in some sense defend ourselves and defend the education approach against denialism and against the attack on science. And for that, I would like to introduce you Ms. Eleftheria Tsourlidaki. Eleftheria has been in Ελληνογερμανική. She's a researcher. Her main interest is big ideas in science. And she has been a Playing with Protons trainer with us in CERN. And she's been using some exciting ideas to introduce issues like climate change in the classroom. Eleftheria, the floor is yours.
Thank you, Stefanos. Hello, everyone. Welcome to our conference, even though we're halfway through already, I guess. Like Stefanos said, I work at Ελληνογερμανική Αγωγή. My main work for the past 8 years is based on the big ideas of science, which is essentially about how do we give meaning to what students learn. And I would like to take this opportunity to invite you all to the workshop right after this one, which is exactly about that and about how to give meaning to students' learning and how to increase knowledge retention. Among the things we are doing is presenting different subjects, especially controversial subjects and very important subjects like climate change through different ways. We very often talk about STEAM. Most people, when they hear STEAM, they have something very specific in mind, and most of the time we focus on doing exactly what we used to do, basically science, and sprinkling a little bit of something that is artistic on top, and then we call it STEAM. So in what I am about to present you, I would like to change that around. Aside from being a researcher in Megromaniki and a physicist, I am also a very passionate crafter. I really love doing working with art and doing artwork. So I've tried to take all this experience I have from my personal crafting journeys and take them into the classroom. And we've been trying to focus on STEAM, but the art flavored STEAM. So focusing on art and giving art the floor and having science, technology, and engineering playing the support roles. So I'm going to share my screen with you. I suppose you can see my presentation now.
Yes, we can, Lefteria, thank you.
Okay. So what I'm about to show you, it's an activity about climate change. In fact, there are 3 activities about the debates around climate change and climate change as a phenomenon overall. We have a set of 3 activities. One is tackling the scientific, is addressing the scientific part. So we're strictly looking into climate change through the science behind it. A second one refers to the open schooling aspect and how we can bring, how can we increase people's awareness around climate change in our local society. And the third activity, which is the one I'm going to present to you today, is about the art behind what we can do about climate change through art. All of this and many more we have been playing around with in an Erasmus project called In STEAM. This is the URL. I'm not going to go on and start explaining what the project is about because I really want to focus on the fun stuff. So feel free to join us in our website, check out the project, check out what we do, and register to become part of our implementation team. So one of the things we focus, as I said, is art. And we're keeping a big capital A into the STEAM abbreviation. So art and science, how can we combine art and science and art and STEM in school? Well, there are many different ways. Like I said before, most probably people, what they do is during a science class, they add a little bit of a small art component. But there are many different ways to combine art and science. These are 3 suggestions for you. One is to use science, technology, and engineering as a source of inspiration to do art. You can any given science article, any given technological achievement, any given engineering problem can be a source of inspiration to create art and to communicate what you feel and what you have in mind and disseminate all these things through art. So one way to go is to draw inspiration through STEM. A second way that you combine these two is to do art following a scientific research process. So actually do a scientific inquiry, but changing it and tailoring to the needs of an art class. And the third way that I would like to propose to you is using art to communicate science in an engaging way. So I'm going to go briefly through all these 3. I'm going to start with drawing inspiration from STEM. So to increase students' appreciation of STEM and help them draw inspiration from it, think next time you do an art-related activity with your students, try to find, a science activity with your students. Try to find the connection of the standalone subject that you're teaching into to real life, and try to connect that to your students' everyday life and have them ponder upon all those things and allow them to express their ideas and the feelings and all the things that they think beyond the actual content of the concept, and help them put that on a piece of paper or on a keyboard. besides, when we're teaching our students any given concept, besides from learning the concept itself, we might also want to change a little bit the focus that we have and allow our students to zoom in different parts of what we're teaching them. So when we're talking about principles in physics, for example, of course, we're going to teach them that principle, but it might also be worth to check other things like the symmetries behind it, the shapes. When we're talking about electromagnetism, for example, or when we're talking about sound waves, I bet you have all seen numerous videos on YouTube where you have like this big table and you put sand on it, and then you vibrate the table and all amazing shapes come into life. And this is an artistic way of demonstrating different properties of sound waves. So think about zooming in into the little details about the concept that you're teaching, not just the principles, but the shapes, the symmetries that are involved, and help your students get inspired from that and start zooming in on that and creating their own artwork based on the inspiration that they're getting from the principles that they learn. Another interesting thing to do is to visualize phenomena, just like the example I mentioned earlier about sound waves and how sand dust responds to sound waves. Is an excellent way to visualize that phenomenon. There are many things that we teach our students in science classes that have to do with invisible phenomena or with things that we cannot really see. Art can be an amazing vehicle to allow your students to visualize this phenomenon. And I guess you have also seen a lot of pictures, especially when it comes to astronomy. You've always seen, I'm sure you've all seen pictures of black holes that are artistic representations of black holes or galaxies or nebulas. So there is a lot of art in the game when it comes to visualizing and to making something visible out of something invisible. And when it comes to the second bullet point, so making art that's following a scientific research, I don't know if you feel the same with me, but being a crafter and a physicist, I always found a perfect harmony between the two. And I always found that the processes you go through as an artist and the process you go through as a scientist are very, very linked and close together, and they're actually more or less the same process. So when we're doing art with our students, it's not enough to just let them draw a picture. You can actually follow a very particular structure that will help them do this right. They can start with an orientation phase that will help them dive into the subject. If we're talking about designing art based on something that is coming from the scientific world, so a concept or anything like that, they can even start zooming into the subject by looking into the science behind the concept itself. They can start then moving on to the conceptualization phase. They can start digging into other artists' work and search different artworks that are related to it and draw inspiration from them. And then when the time comes to get creative, they can, which is the investigation phase, if we would be talking for a scientific inquiry, then at that point you dive into the artwork that you found, you study it, you see what you find, you see what you like, you see what you don't like, you get a lot of ideas out of that. And of course, don't copy paste that, but you get inspired by that, and you use different elements to create your own unique piece. So you reflect on that artwork, and based on that reflection, iterative process, you start creating your work, and then you present it to everybody else. And very closely linked to this scientific-like research project process, You can always do something similar to communicate art, to communicate science through art. And since we're talking about communicating science, we're talking about raising awareness. So it's very, very closely linked to the whole idea of open schooling. So in that case, you can follow a more open schooling oriented set of steps to create art with your students. In this case, we dive into the subject at hand again, but we're also looking at it from different aspects, more closely to the society, for example, not just focusing on the concept itself. Usually when we're doing open schooling activities, we focus around one problem of the society. So in this case, the subject is not necessarily a standalone science concept. It's a problem of the society, and maybe that is also probably related to a science concept. So in this case, feel is about diving into the subject, not just in terms of the sterilized content, but also strongly linked to the views and the problems of a society. Then you move on to the imagine phase, where you try to brainstorm and imagine how you could start putting this into this subject into an artwork. You have to decide what are the main messages you wish to communicate with your art. You have to decide what kind of art you will do, and to do all that, you also have to keep your target groups in mind, because we're talking about communicating science. So the target group in this case is really important. It's not just a piece of work that I'm creating to express myself. I want to make a point out of it. So the target group in this case is more important. Then you move on to the create phase, where you make art, you show it to your students, you reflect on that, you exchange ideas, you might change your artwork a little bit. You want to make sure through that reflection phase that your main message is getting across. And when you're done, you would go to the share phase, where you actually present your artwork to the local community. So these are the three different proposals that we have to you about how to do STEAM, focusing on art and giving art the main role in display. And moving on, before I show you an actual example, I'm going to go very briefly through some ideas and some suggestions. One thing I would like to mention is that through this whole activity, we also want to get students to appreciate art on top of science and learn how to really look into art and appreciate and be inspired by it, and start paying attention to details and try to look into the different hidden messages. So these are also things that we do through science. We want to be looking into the details. We want to find meaning into what we're doing, and we want this to happen with art as well. I'm going to introduce to you my favorite tool, which you also see in the activity. It's called a mood board. Mood boards are basically visual representations. It's like a collage which aims to reflect all the things that you have in your head. So when I make a mood board, I basically make a composition that reflects all the different ideas that I have in my mind. And that collage can have images, it can have different tags or texts, it can have different objects, different materials that I would like to use. So you're basically putting together all the ideas that you have in your head, like a soup. You put them all down, so then you can use all that soup to start making something meaningful out of it. And this is a super nice tool because it can help students brainstorm a lot. Because it's something visible, then it can help them reflect on what they're doing. Because you're asked to actually communicate what you have in your head, you are also prompt to take initiative. It helps you decide where the focus of your artwork is going to be, and it's definitely the first step to being creative. The most important thing about mood board is that it's the perfect way to overcome what we call the artist's blank page syndrome. It's something that happens to artists very, very often. You want to design something, but the first step is the most difficult. You don't know how to get started. So you have a blank page in front of you and you don't really know what to do with it or how to get started with. And mood boards are an excellent way of overcoming this, especially when we're talking about students, younger children that are not very used to doing a lot of art. This tends to happen. So this mood board is a great way to overcome that. And I will also talk about, I want to talk about the processes and the artistic inquiry. And this is what I was talking about, that is very closely linked to actual scientific inquiry. Because just like science, when you have a hypothesis or a very scientific question to answer, here you have an objective as well. There is a message that you want to communicate. It might be something personal or not. Just like we do an inquiry, you have to take initiative. The only way to get to create art is to improvise and to do whatever you feel like doing. Students, you need to encourage your students to decide on the materials that they want to use on their own, decide what they want to do. And this is more or less like setting up your experiment. You're deciding what tools you're going to use and how you're going to do it. You can experiment with different processes, different materials, different ways to use your materials, which is essentially just like using your setup in different ways and doing different types of experiments for the same investigation or hypothesis. My favorite thing above all, encouraging our students not to be afraid to make mistakes. Even when you're doing art, students are afraid that they will mess up their artwork and they're afraid to do things. And we're always trying to encourage them to not do that and try anything that they like and see how it goes. And it's exactly the same in science. Students are afraid to make mistakes, and that takes away opportunities for them to learn. So increasing initiative and self-confidence. And last but not least, in art, you're always asked to explore different paths. You are always asked to challenged to dive into uncharted waters. And this is the perfect twin sister or brother of open experimentation, when you're asked to design something from scratch and explore something that is completely uncharted. It's a completely open experimentation. And moving into climate change in particular, when it comes to art, we have several problems why we can't get the message across, and art a good way to start. One thing is that people think that climate change is a distant problem. It's something that will happen in the future. And on top of that, it's an invisible problem. It's not something that we can actually see. Like I saw in a video, someone was saying that if CO2, if carbon dioxide was black instead of invisible, we would have dealt with climate change ages ago, because it would actually be visible to us. The third challenge is that climate change is not immediately affected. We think that climate change doesn't immediately affect us. Due to this all this debate and with people that benefit from CO2 from different industries, there's this whole debate about whether climate change is real or not, which is obviously not a debate, but it is in many people's minds. Another thing is that when it comes to climate change, I personally often feel that we communicate the wrong messages. If you really think about it, climate change is not about saving the planet, it's not about saving the environment, it's not about saving any other species, but ourselves. The main impact is going to backfire on us. We're talking about climate change and mitigating climate change. What we primarily want to do is to actually save humankind, because in a few years from now, we're going to be in big trouble. We're going to have big troubles. And last but not least, whenever you hear about climate change, there is this doom and gloom hovering feeling that people get. And this is something people naturally try to avoid. So you always throw it under the rug and you leave it there. So when it comes to climate change, it's important to take all these aspects into consideration when you're actually trying to communicate that. So we have designed an activity for that. It's called Climate Change Real or Not, an Artistic Point of View. This is the link. So you can go on and have a look at it. Do I have Stefanos time to guide you through the activity super quickly?
Yes, you may do that. You know, we're not going to have any questions because we're out of time anyway. But you have 1 minute to wrap it up because it's nice to see the questions on the actual tool. Yes, thank you.
Okay, so can you see my screen, my browser actually?
Yes, we can see.
So this is the activity. I'm going to go super quickly through it. I'm using the scientific inquiry that I told you about. So in the first, you're supposed to do this activity after doing the scientific activity. So students have really learned about climate change. So I start with a little bit of diving into the problem again. Just a quick wrap up. I asked them to do a quick activity. And then I asked them to go online and wander about the internet and find pieces of art that are related to climate change from other teachers. From other artists. So I asked them to collect interesting pieces of art related to climate change. Then I asked them to go over them, to think about them, think about what they like to keep from each little piece, put them all together, and then I asked them to think about the message they want to communicate based on the things that the challenges that I talked to you about earlier. And then I'm asking them to create their own mood board. And then this is, I have a mood board example here that I would like to share with you. So this is the part that I asked them to create the mood board, their mood board based on the art that they have, that they saw, and the messages that they want to communicate. So this is an example artwork. It has images, it has phrases, it has tags, it has colors, it has, if it was a tangible one, it would have other materials on as well. So then they're using this as their main tool to decide what they want to do. So they go on, they create their art. We give them guidelines about what to do, what to avoid, and how to do that. Then they share their artworks with their peers, mostly to check and test if they're getting their messages across and what other messages the students derive from what they saw. Add a few final touches to the artwork that they created, and then presenting it to everybody else, to maybe an exhibition in the school or whatever else they want. The main thing that I want to point out about this ILS, except from the actual hidden scientific structure of it, it's that it's completely open. It's not about painting, it's not about music, it's not about theater, it's about all kinds of art. So students are encouraged to decide on their own what kind of art they want to create. Based on what they decide, they can be grouped up by the teacher and work on their own expressions, and then they can do a festival or an exhibition or do it in a science fair or whatever else, and spread the word and communicate their messages to the people. So this is the activity. Thank you very much for taking the time and sticking around to listen to me. Like I said, we have another workshop coming up. You're more than welcome to join me there as well. Special thanks to Stefanos and Angelos for inviting me today.
Eleftheria, thank you very much. We're out of time. There is a session coming on. I would like, if you're I just want to wrap up, and maybe Angelos would like to say something. I wouldn't mind if you want to turn on your camera so I can take a nice picture of those who are present here. Unfortunately, that cannot be the case with those who are following us on YouTube. This presentation and this video will be available on YouTube as well, but will also be we would probably break it into sections in order for you to have access to it, not as a whole thing. Thank you to all the presenters and all the participants. This was another Playing with Protons event. We are going to have a few of them, and especially in the context of the INFN's opening its arts and science across Italy to Greek schools as well. Now, this is going to be, I think, quite interesting and quite major for Greek schools. And once again, we would like to thank the INFN for this. As I said, the details are yet to be how do I say, put forward. Angelos might want to say something about it as well. Once again, thank you very much. There is another session coming up with Eleftheria. She's actually the host. There are also a few things also taking place today and tomorrow in this Open Classroom conference. Angele?
Yeah, I don't want to keep Eleftheria from switching to the next session. So thank you very much, Eleftheria. This is a really, really cool and structured way that we might want to use it as a pathway, or as a and a tool for the Greek pilots. I mean, it's nice to have this this tool for students and for the teams of students, and it seems really helpful actually, and resonates very well with PG's approach, because both projects are taking art, as the main vehicle really to tap into a science subject. And I really liked also the methodology, which is, as you said, hidden, but it's there, especially for the teacher.
Under normal circumstances, Stefanos and I would be sitting one next to each other and talking about it, and I'm sure we would be, come up with a lot of ideas. But I think even from a distance, we will definitely talk about it and see how we can work together again to make this better for presented to the students and to the teachers.
It's great. I would also like to thank Christos a lot for his nice presentation. Really impressive, the video. I really like the video, and the drone that was zooming out. And you've done a great work. And the challenge there that is that you have to keep the curriculum in mind. So you really combine it, in the most creative way possible. And congratulations for that. And thank you very much for being one of the best members of the Play with Protons community. So I see some other familiar faces. I see Angeliki. Hi, Angeliki. Very nice to see you.
Vasilia is here as well, and a few of the Playing Group participants, Ivoni and Marina, are on. I see them on YouTube. They are making comments on YouTube. A few.
Maybe PG wants to say the final word.
Yes,
before we close.
That's what I say. Anese is here as well, but I'll leave the final word for PG.
Yes, I want to thank you, Stefanos and Angelos. Thanks a lot for inviting me. I hope we can continue working together. And Angelos, this is our ideas, not my ideas. So you, me, and Michael. So you remember some times ago, we were younger, but okay. Let's go ahead. Let's continue.
Thanks a lot.
Thank you. Ciao.
Ciao.
Thank you very much. We'll see you soon. Bye-bye.
Bye, everyone.
See you soon.
Bye.
Bye-bye.
Bye, everyone.
Bye-bye.